Alright, I'm just doing an experiment with my oscilloscope on my house. So on my house supply, I got 120 coming in here and 120 coming in here. Well, if you 120, if you put a circuit breaker on both, you're going to get 240 volts, which I need to hook up for my welder. But what I wanted to check, well, let me show you this real quick. You got 120 coming in, 120 coming in, and then your neutral return there. 120, 120, neutral, and if you go to both bars, bus bars, you get 240. So I got an oscilloscope hooked up, my ground onto the ground bar, the neutral bar, and then I got a one lead, channel A on one, channel B on the other. So if I look at my oscilloscope, I'm looking at the sine wave, and I wanted to see the phases, and I just wanted to make sure that they were lined up, which they are a little. If you put those overlap to each other, if you go down here, because let me stop it and I'll start it again. Again, I got a phase here, or 120 on one, 120 on one, but if you overlap them, you can see they're not directly over each other, they're split between the middle. If I see the frequency, it should be 60 hertz. Yeah, 59, 60 hertz, which obviously is what we have here in America. But if I pause this and I look at the peak voltage, because obviously your RMS would be your root mean squared, would be an average. Let me try something here. Let me turn channel B off. Go to just channel A. That's just one of the legs to the ground or neutral bar. And then let me go cursor to the top. Yeah, so the peak to peak 180 to 170 roughly from top to bottom. Let me just check that again with max min peak to peak. So the frequency 60 hertz, max 176, 177, minimum 177, because that's your peak voltage, and your peak to peak is that, obviously. But if you had RMS, your RMS would be like a mathematical formula of root mean square would be in there somewhere, and you get like 120 volts, but you could put another measurement in there and go DC or AC RMS. Okay, 126. So max 177, min 177, peak to peak 355, AC RMS 126. So if you're using a DMM, digital multimeter, you get to 120, 126 volts. Then if I turn channel A off, turn channel B on, which the other 120 leg, I'll get the same thing, max, min, peak to peak, frequency, AC, RMS. Again, max 174, 175, 176 for min, peak to peak, 350 some, RMS 125, frequency 60 hertz. If I go back to A, I got both A and B on now. So put these together, you can see it's running live right now. I'm playing, but you put these over each other, you can see it splits the difference. Just thought that was pretty neat. The peak of this is the bottom of this one, and so forth. Just trying to show you that there. So if you wanted to figure out your frequency, what you could do, I mean, it figures it out there, but you could put your cursors in here. We know it's 60 hertz. You could go to the center of that. You go to the center of that. You can do the difference between the first and the second cursor, 16.6 milliseconds. You take, 1 divided by the period in seconds. You do your conversion, how many milliseconds are in a second. Take 1 divided by, I think it'd be 16.6. 1 divided by 16.6, but it'd actually be, let me do the math real quick. The math would actually be, so it's in seconds, 1 divided by the period in seconds. So you take 1 divided by 0.0166, not 1 divided by 16.6. You'd have to move your decimal over, so to do it on a calculator, take 1 divided by 0.0166, and you'll get your 60 hertz from there to there. So let me play it again. So yeah, move this one over. You can see how it splits it, and that's again 120 on one leg on the left and 120 on the right leg. And of course, if I measured across both of those, I should get my 240. Alrighty, so what I'm doing now is I got just one lead. I got one channel on, which is channel A on the oscilloscope. And I got a positive, negative lead. I got a positive on one, the 120, and negative lead on the other 120. So I should get around, I think it's like 240, 120 and 120. You should get 240. So turn my scope on. See the sine wave's a lot bigger. We'll just go to measurement, max, min, peak to peak, ACRMS, frequency. Max 352, minimum 353, peak to peak 706, ACMRMS, 253, roughly right there. And this frequency is still 60 hertz, obviously, because I'm measuring the 120 coming in. I do got a little bit more than 240, obviously, but that's showing that. So I just wanted to show that on this video. Thought it was kind of interesting how the sine waves, I wasn't sure if they'd match up completely or if they'd be like the results we had where they're one peaks to the top of the peak is the center of the bottom of the other peak compared to the 120 for each leg. So that is it for this video.